Welcome to this M1 video on vectors. So solving problems with vectors written using I and J notation. So quite a bit of this is effectively done in the last video, okay, with just a little bit kind of new, a little bit extra added in. So I think what we will do is jump straight into the first example and go from there. So here's the first example, and I do feel like we pretty much covered this in the last video, but just sticking with the order from the textbook for those of you following in the textbook, this will, just make sense. So the vector v is equal to p minus 2q. Given that p is 3i minus 5j and q is 5i plus 7j, find v in terms of i and j. Hence find the magnitude of v. Missed out the e there. And then finally the angle between v and the positive y-axis. So let's start with a. So v is p minus 2q, which is 3i minus 5j minus 2 lots of 5i plus 7j. So that's 3i minus 5j minus 10i minus 14j. So if I look in terms of I, I've got 3 minus 10, so that's minus 7i. And then look in terms of j, we've got minus 5j and minus 14j, so that is minus 19j. So that is part A done. Now B, hence find the magnitude of V. So the magnitude of V, we write v in the modulus sign, and this is this minus 7 squared plus minus 19 squared, and then square rooted. That's the square root of 410, or in decimals is 20.2 to 3 significant figures. So that's my part B, and then part C, find the angle between V and the positive y-axis. So if I sketch an XY set of axes here, and then we've got minus 7, minus 19, so we're going down this direction here. So this is my V, and we want the angle between V and the positive y-axis, so we want this angle here, theta. Okay, now it's 19 down and 17 across. It's actually minus 7 and minus 19, but I can forget those when I am dealing with the angles, and we want first to find this angle alpha. So to find alpha, I want tan alpha equals, now it's opposite over adjacent, so that's 19 over 7, inverse tan of that, and I get 69.8 to 3 significant figures. Now theta is equal to alpha plus 90 degrees. So adding 90 degrees to that, I get 159.8 degrees, or 160 degrees to 3 significant figures there. Okay, depending on what level of accuracy you want to do this. And I feel like a lot of this was basically covered in the last video. However, the next example wasn't. So in this question, I'm given two vectors, a and b, and find lambda if a plus lambda b is parallel to the vector j in the first instance. So how do we go about doing that? Well, first of all, let's write down what a lambda b is. So that is 8i plus 3j, that's my a, plus lambda I minus 4j. So let's expand this. So it's 8i plus 3j plus lambda I minus 4 lambda j. So if I collect my i's together, I've got 8 plus lambda I plus 3 minus 4 lambda j. Now, since it's parallel to the vector j, it has no I component. So what I want to look at is the I component being 0. What value of lambda makes that I component 0? So that means I want 8 plus lambda equaling 0. Okay, because it's 8 plus, lambda I equals 0i. So my lambda equals -8. And that is the answer to the first one. So when lambda is -8, this vector is then parallel to j. Now, for part B, we want it parallel to I plus j. Okay? So we want the I component of, or the component of I and the component of j to be exactly the same because they're the same size. So what we want for part B is we want the 8 plus lambda to be equal to the 3 minus 4 lambda, so that the components are the same. So that means that adding my 4 lambda and then taking away 8. So lambda equals -1. Okay, and that therefore is parallel to I and j. And you can see what happens when you substitute it in. So if I substitute the -1 in, I get 7i. And if I substitute -1 into here, I get 3 plus 4, so that gives me 7j. And that 7i plus 7j is parallel to I plus j, because you can take that common factor of 7 out. That just gives it its size. Okay, so that is the new bit, parallel to. Okay, so if you found this video useful so far, don't forget to hit that like button. Also hit the subscribe if you are yet to subscribe, and hit the join if you're willing and able to help me out. Otherwise, let's look at some questions. So the first question is just a little like warm up, you could say. And then the second and third questions are the parallel ones. And the fourth one is just then putting it in terms of bearings. So nothing too challenging there. Okay, obviously I haven't shown you how to do like B and C. So on question 3, so have a go at those. And then, stay tuned for the answers if you want to check your answers or see how it's done. But otherwise, pause the video now. Okay, welcome back. Let's look at the answers. Okay, so A plus B is 7i plus 6j plus 3i minus j. So that's 10i plus 5j. Okay, B, 3a. So it's 3 times 7i plus 6j, 21i plus 18j. And C, 2a minus 3b. So that's 2 times 7i plus 6j minus 3 times 3i minus j. So 14i plus 12j minus 9i plus 3j. So 14 take away 9 gives me 5i, and 12 plus 3 gives me 15j. And that's question 1 wrapped up nicely. Let's look at number 2. Okay, so part A, we're doing P plus lambda Q. So that is minus 2i plus 5j plus lambda times 2i plus j. Okay, so that is minus 2 plus 2 lambda I plus 5 plus lambda j. So that is my i's and my j's. So it's a plus there, sorry, don't know why I wrote a minus. Okay, so these are parallel to the vector I, which means there is no j. So 5 plus lambda equals to 0. Lambda equals negative 5. Let's do B. So we got mu P plus Q equals 2. So that's mu times minus 2i plus 5j plus Q, which is 2i plus j. So that is minus 2 mu plus 2i and 5 mu plus 1j. Okay, and this time is parallel to the vector j, so the I vector is 0, so minus 2 mu plus 2 equals 0. So 2 mu equals 2, mu equals 1. Okay, and you can check both answers by substituting them in. So this one I substitute into here, I get, minus 10 and minus 2 is minus, so I get minus 12i plus 0j, which is what we want, just a vector in terms of I. And when I substitute 1 in to this one, I get minus 2 plus 2 is 0. And then this is 5 plus 1 is 6. So I get 0i plus 6j, and that is parallel to the vector j. Okay, so nice and straightforward. Let's look at question 3. Okay, A is r plus lambda s. So it's I minus 2j plus lambda 5i plus 2j. So that is 1 plus 5 lambda I plus minus 2 plus 2 lambda j. This is going to be parallel to I plus j, so the i's and the j's are equal to each other. So therefore 1 plus 5 lambda is equal to minus 2 plus 2 lambda. So that gives me 7 lambda equals minus 3. So lambda equals minus 3 over 7. And substituting this into here, we'll get minus 8/7 for both of these, therefore parallel to I plus j. So that is nice and straightforward, but from part B onwards that I hadn't shown you, so let's see if you managed to do it. So we've got R plus mu s, so that is I minus 2j plus mu times 5 I plus 2j. So that is 1 plus 5 mu I plus minus 2 plus 2 mu j. Now this time we want it parallel to I plus 3j. So to get an equation that is equal, that is going to mean that the j, which is minus 2 plus 2 mu, is going to be equal to 3 times that I. Okay, to make this so that it's 1i and 3j, we've effectively got to times the I by 3 to equal the j to make them actually equal for an equation. Okay, and then solving this we get 3 plus 15, so that is 13 mu on this side minus 5, so mu is minus 5 over 13. And if I substitute this into here to check it, I get minus 12 over 13 for I and minus 36 over 13 for j, which is 3 times I, which is what we want. Now we use a similar process for part C. So we've got S minus TR. So that is 5i plus 2j minus t times I minus 2j. So that is 5 minus t I plus 2 plus 2tj. Now this is going to be parallel to minus 2i plus 3j. So to make this equal, we want 3 times the I component and minus 2 times the j component. Okay, so you're basically applying these to the opposite components, which will therefore make an equation. So 15 minus 3t minus 4 minus 4t. So taking the t's to the left, we get 1t, and then taking the numbers to the right, we get minus 19. And if I substitute this back into here, the original, we get that this side is 24i, and this side then is 36j. And you can see if you take 24 divided by the minus 2, you get minus 12, and times by 3, you get the minus 36. So it does work with this. Okay, so that is how I deal with these parallel vectors. So you may get a question on this. I have seen questions, or like a part of a question, where it does ask for a parallel vector, something parallel to something else. Okay, so now you know how to do it if you couldn't work it out yourself. Anyway, let's look at question 4. So we're looking at A, just sketch my x, y graph, and we want -3, -1, so somewhere like that. So -3, -1. Okay, now in terms of the magnitude, that's quite easy. So -3i minus j, the magnitude of that is going to be the square root of 9 plus 1, or root 10. Okay, in terms of the angle, well, let's find this angle first. It's alpha, and tan alpha is opposite over adjacent. So inverse tan of 1/3 gives me 18.4 degrees to 3 significant figures. Now, for a bearing, that is going to be measured from north. So ultimately, we want this angle here. And it's not so easy to work that out. We could do it a couple of ways. Well, it is easy, I should say. So we could do, like, this is 90 degrees. So we could take 90 alpha away from 90 degrees and add it on to 180. Or we can add alpha to 90 degrees here to get this angle, and then take it away from 360. But this theta is what I am finding. So I'm going to say it's 360 minus the alpha plus 90. So add 90 degrees to the alpha, we get 108, and 360 minus that gives me 252 degrees to 3 significant figures. And check that the answer makes sense. It's greater than 180 and less than 270. So that is what I was expecting. Now B and C are very similar. So B now is, B is probably a little bit easier. 2 across, 4 up. Okay, so we want this alpha here to be able to find our theta. So the magnitude is going to be of 2i plus 4j. The magnitude is 2 squared plus 4 squared. So that's the square root of 20, which is 2√5. Tan alpha is opposite over adjacent. So it's the inverse tan of 2, 63.4 degrees to 3 significant figures. Theta is 90 minus alpha. So 90 minus my answer is 26.5. So we'll do 27, so 0 to 7 degrees to 3 significant figures. Okay, and there we have the second answer. And part C, again, a little sketch just to see where we are. We want 5 across, 1 down, so somewhere like that. So 5 across, 1 down. There's my alpha, and my theta is all of that. Okay, so first of all, the magnitude. So 25 plus 1. The square root of 26, and then it's bearing, So that's going to be opposite over adjacent, so 1 over 5, and the inverse tan of that is 11.3 degrees. And then theta, our bearing, is 90 plus alpha. So add 90, we get 101 degrees there. And there we have it, the end of the video. Hopefully you found this one easy. I think, a lot of what's in this video is in the last video. So, you might have been able to skip bits in this one. If you didn't watch the last video, just watching this one is more than enough. Next video coming up is the velocity of a particle as a vector. So that then is, I would say, something quite new. And then following that, we'll be looking at velocity and time, solving problems with velocity and time using vectors. So some, I want to say exciting, but certainly, maybe not exciting for everyone, but definitely useful videos coming up.